Let me go ahead and get going on this. So we did one Simpsons rule problem last time that I had you out on. Another thing that you can do, and I'm not going to derive this or anything, but there's a connection between Simpsons rule and the trapezoid rule. So you'll see this like on your homework. It's just kind of a nice thing to show students. And the thing about this is it's kind of a weird relationship. So what this is saying is Simpson, that stands for the Simpsons rule. And remember, Simpson's rule was basically based on a parabola, so it gave us a little bit greater accuracy than the trapezoid rule. And then the T stands for setting up the trapezoid rule. So it turns out if you had an estimation of the trapezoid rule and kind of have a table like I have down here, then you could do the Simpsons approximation based on the trapezoid rule. So a lot of times it's easier to do the trapezoid rule and then do Simpson's rule based on this formula right here. So the idea with this is, and you might want to write this down just as an example. So like if you had S of, say, 10. Now what that would mean is that would be Simpson's rule. What does that 10 mean? That's like 10 intervals, right? Okay, so that's like the subdivision. So you would have that. So you'd have 10 trapezoids, or 10 units for Simpson's rule. Okay, what this says that you do is you do 4 times the trapezoid rule for the same thing. At 2n matches that. So that's 10. And then when this says t of n, that's going to be half of that. So that's going to be t of 5, like that, and it's all over 3. Okay, that over 3 has a lot to do with the fact when you're doing Simpson's rule, and I didn't get very technical on Simpson's rule, I just showed you the formula, is when you develop that, generally if you're making a parabola, generally it's based around 3 points on that parabola is where the derivation of that formula comes from. So the idea is you can get a Simpson's rule approximation if you already have a trapezoid approximation. So what I have you usually do on the homework is this. It's not too hard. Generally what I have is a table like this, and if you were going to do the Simpsons rule for 8 subdivisions, then what you could do is you could look up the trapezoid rule approximation for the same. So what I was looking at on here is you have the trapezoid rule for 8 right there. Now let's just say that's already been crunched out. Okay, then you could look up the trapezoid rule for 4, and let's say that that's already crunched out. Well, what you would do on this then, if you were doing the Simpsons rule for the 8 intervals, then you would do 4 times this value right here, and I'm not going to write all those decimals, it's like 0.2629 and so forth like that. It's that row right there, minus the this thing, which would be 0.259, then the rest of the decimals, and then divide by 3. So if you work that out, you would get that approximation right there. And what this table is, I took this out of the book, is if you computed Simpson's rule 8, then you would get this right here. So that's a pretty simple thing to do, is that. So if you know some information on the trapezoid rule, then you can figure out Simpson's rule. Does that make any sense? It's a simple formula. The other thing I wanted to show on here is just this. We talked about this a little bit last time, is notice we did the errors. And remember, the reason we have errors is because this is an approximation versus getting the exact answer to an integral. So one thing I want you to notice on there is, what do you notice about the error in the trapezoid and Simpson's rule typically? Yeah, that's a little more accurate. Look how accurate that is. Man, you start to get down to 128 intervals. That's probably, for all practical purposes and engineering and stuff, that's real accurate. It doesn't matter that you're getting out that far like that. So Simpson's rule is typically the most common numeric approximation of integrals. I think your calculator, even your TI, probably does Simpson's rule. I'm not sure about that, but I suspect it's programmed to do that. It does one of the two, but I think it's Simpson's rule. So that's the idea. So I'll have you do one thing on the homework like that. You're not crunching out everything with Simpson's rule, but you're taking a table and using that approximation, okay? That's not a big deal. On that, just look up your formula. So I don't want to spend much time on that. So I pretty well have shown you everything that you need to know on here.